In the history of mathematics, few conflicts have been as heated, prolonged, and consequential as the battle over the invention of calculus, a dispute that involved two of the greatest minds in history, Isaac Newton and Gottfried Wilhelm Leibniz. This was not just a fight for intellectual supremacy, but for the birth of a revolutionary idea that would forever shape modern science. Isaac Newton, born in 1643 in England, was a mathematician, physicist, and astronomer whose discoveries in motion and gravity changed our understanding of the universe. Yet, one of his most significant achievements was kept hidden in private notes for many years. It wasn't until 1687 that Newton's Philosophiae Naturalis Principia Mathematica was published, laying the foundation for classical mechanics. Meanwhile, across Europe, in Germany, the brilliant polymath Gottfried Wilhelm Leibniz, born in 1646, was developing ideas that would challenge Newton's theories and rival his claim to the invention of calculus. Leibniz, known for his systematic approach, is often credited with creating the notation that continues to shape modern mathematics to this day. Though separated by both time and borders, both men independently arrived at the concept of calculus, a new mathematical language that described change, motion, and the infinitesimally small. Newton called his method fluxions, reflecting the flowing nature of change in his work on physics. In contrast, Leibniz viewed calculus as an abstract, algebraic system, and he introduced symbols like the integral sign and the differential d, notations that became central to calculus for centuries. In 1699, Leibniz published his findings, introducing calculus to the European mathematical community. His revolutionary ideas quickly gained popularity, but this success triggered a storm of controversy. In England, Newton's followers were quick to accuse Leibniz of plagiarizing Newton's unpublished notes. After all, Newton had developed his fluxions years earlier. Leibniz, however, maintained that his discoveries were independent and based on his own reasoning. The Royal Society, where Newton was a key figure, took up the case. Under Newton's leadership, a report was written accusing Leibniz of plagiarism, alleging that he had seen Newton's unpublished notes. Despite the lack of clear evidence, the Royal Society concluded in 1712 that Leibniz had copied Newton's work. Leibniz, however, strongly defended his innocence. He pointed out the differences in their methods and notations, claiming that his ideas had come from his own reasoning, unaffected by Newton. Despite his defense, the damage was done. The intellectual battle had begun, and the war would continue for decades. The dispute between Newton and Leibniz would have a profound impact on mathematics and science. Newton's followers continued to use his fluxions method in England, while Leibniz's notation spread across Europe, eventually becoming the standard for calculus. Though the two men never reconciled, history now recognizes that both independently discovered the core principles of calculus. Their contributions laid the groundwork for modern mathematics, physics, and engineering, reshaping the way we understand the universe. In the end, the war over calculus was not simply a battle of ideas, but a clash of pride, politics, and personalities. The true victory lies not in the intellectual dispute, but in the enduring power of calculus itself. It remains a tool that continues to unlock the mysteries of nature, from the motion of planets to the behavior of particles, and shapes the way we view the world today.